So this is the end-to-end throughput and bottleneck links. So consider the scenario shown below, with 4 different servers connected to 4 different clients over 4 3-hop paths. The four pairs share a common middle hop with a transmission capacity of R equals 300 megabytes per second, or megabits per second. The 4 links from the servers to the shared link have a transmission capacity of 10 megabits per second. Each of the 4 links from the shared middle link to a client has a transmission of RC equals to 100 megabits per second. What is the maximum achievable throughput in megabits per second for each of 4 client to server pairs, assuming that the middle link is fairly shared, divides transmission rate equally? So, for this question, the simplest tip I can give is the lowest number, right? Because 10, like the lower the number, the more likely it's gonna be, right? So it's 10. Now, which link is the bottleneck link? So to define a bottleneck, it is basically what part is not able to catch up to the rest, right? Which means what is holding back, which item is holding back everything from being used to their full potential. In this case, it is the server, RS, because the throughput, right, the network can handle up to 300 megabits per second. The computers can receive up to 100 megabits per second. But then the servers is only sending up to 10 megabits per second, right? So the computer can't process enough data quickly enough because the server is being too slow with sending them. That means RS is the bottleneck link, right? Assuming that the servers are sending at the maximum rate possible, what are the link utilizations for the server links RS? Answer as a decimal. So, what this basically is, right, is RS over RC, right? So it would be, what link is it? It should be 0.1. But let me quickly check on my calculator. Okay. So wait, I made a mistake. I didn't read the question properly. It's saying how much. This question is a bit confusing, right? Assuming that the servers are sending at the maximum rate possible, what are the link utilizations for the server links? What this question is basically saying is that how much of the data can the computers take at once, right? So that means it's 100 divided by 10. And since it wants the answer as decimal, it's sort of like percentage, right? So it can so the short answer is that it is 1. The reason why is because if the RC has a bigger receiving rate than the sending rate from the server, it means that the computer will receive everything better than the server will be sending. Meaning that meaning that it's going to take everything at once. And now, assuming that the servers are sending at the maximum rate possible, what are the link utilizations for the client links? Answer as a decimal. Now this should be 0.1. The reason why is because what I did for the last question was 100 over 10. This time it's 10 over 100, right? And it should be 10 over 100, which is 0.1. It's basically saying, right, that what percentage of data is the computer receiving that the server is sending. So if the computer wants to get 100 megabits per second, or 100 megabits total, right, the server is only sending 10% of that. So if this was 20 megabits per second, the computer will be receiving 20% of the data at once. So it's basically just asking how much data is being sent to the computer at once, and then the previous question is asking how much data can the computer take at once. Okay, no, that was a bit confusing. Okay, So this question is basically saying that, alright, from the computer, how much am I actually taking compared to how much I can handle, right? Because the computer can handle 100 megabits per second, the server is sending only 10. So the computer is saying, oh, okay, so I'm only getting 0.1%, 0.1 or 10% of what I'm actually able to take. Compared to the previous question, it's saying, oh, how much of this data can I take at once? Can I take all of it, or do I have to segment it so I can make it easier for me to digest? Right? So that's why the answer is 1 from the previous question, because the computer is able to take everything. Now, assuming that the servers are sending at the maximum rate possible, what is the link utilization for the shared link R? Answer as a decimal. Okay, now this, what you will have to do is, you have to do, what you have to do is, the server data, which is 10, over 300 divided by 4. Now, let me explain. So it's basically how much is the server sending over how much is the network able to handle divided by the amount of devices that are connected to said network, right? Which I got as 0.13. Okay, now here is another variation of the question, but this time it is a bit more difficult because RS is 50, R is 100, RC is 100, right? So if, say, I would write 50 is the lowest number of the lowest, like the highest amount of data that is being able to be sent, because 50 of course is the lowest number, you're going to instinctively write that down, right? But then you have to account for the throughput from R, from the router. So if I check, yeah, it's correct. It's not correct. Sorry, it's not correct. The reason why is because you have to do 100 divided by 4. The reason why is that 200, if you add all of these up, it's 200 megabits per second of data being sent through R, which is only 100 megabits per second of data, right? So 200 is quite clearly, obviously bigger than 100, right? So what you have to do is that for this question, you have to do 100 divided by 4, which is 25, which means if you take 25 from each of these, the network will be able to handle it, right? So if I write down 25, the answer is correct. So now the bottleneck link, right? It's R. Why? If you add all of these numbers in RS, it's 200. R is 100. RC is 400. R is clearly the smaller number, so R is the correct answer. Now, assuming that the servers are sending at the maximum rate possible, what are the links for the server links? Now, that is basically 1, right? It's basically saying how much data can the computer handle that is being sent from, how much percentage of data can the computer take that is being sent from the server? And that is all of it, because 25 is less than 100, so if I write 1, wait, what the? Okay, just give me a second, let me just recalculate. I have made a mistake. So, because I just ran into an issue that is quite common, which I think other people also have the issue with, is that once you account that RS is 25, because only 25 can be sent, right? You have to change the value of RS to 25. So, what that means, right, is because the R is the bottleneck, right? So the bottleneck can only handle 25 megabits per second of data from every server. So it's the bottleneck over RS, right? So it's 25 over 50, which is 0.5. And now for RC, It's basically like RS, but for the computer. So we have to change the bottleneck. So it's 25 over 100, which is 0.25. And now, for the shared link, it is the bottleneck over R divided by 4. So that is 25 over 25, which is 1. So that is another way to approach this question, or that can be given.